Welcome back. With us here is yet another problem on simultaneous equations that we want to deal with. The question says we should simplify the simultaneous equations given below. Use any method of your choice to find the values of the variables a and b. The question we have in hand is fractional in nature. Yes, sometimes you can see fractional problems appearing under simultaneous equations. That's okay, not a problem at all. The most important thing is understanding your earlier concepts of elimination method and substitution method. In case you haven't seen my videos on how to use elimination method and how to use substitution method in solving a simultaneous equation problem, I advise you to leave this, go back, see my video on elimination and my video on substitution. Those will give you hints on how to solve problems on simultaneous equation. Then you can return to this and get it done in a twinkle of an eye. It is direct. All right, let's swing into action. The first stage, as usual, is to write the questions, one being upon the other and the other one being under. Okay, so I'm going to rewrite it as 2 all over a minus 3 all over b is equal to 2. You can write this 2 as 2 all over 1. That's not a problem. This is my first equation. I call it equation 1. The second one is 4 all over a plus 3 all over b is equal to 10. This is my second equation, so I'll call it equation 2. Now, the equation is very properly arranged. That's number 1. Another thing you notice in this question also is that look at the b term. They are similar. 3 upon b is in the first equation. 3 upon b is also in the second equation. What method comes to mind? You can jump straight to elimination method if you want. Yes, it can work it out and it can make our work so easy. And I'm going to start with the elimination method. No need to multiply anything. The question is ready. So the first thing I'm going to do is to add equation 2 to equation 1. Why am I adding? I am adding because only addition will allow 3 upon b to remain 3 upon b. In that case, 3 upon b can easily subtract 3 upon b to eliminate b for me. You see that? Easy. Alright, so since I'm aware of what I need to do, let's swing into action straight away. First, 2 all over a add 4 all over a will give us 6 all over a. Since the denominators are the same, just add the numerators. Now, negative 3 upon b add 3 upon b. It's the same thing as 3 upon b minus 3 upon b. That gives us 0. We have just successfully eliminated the b term. So the next thing we need to do is our constant. 2 add 10 gives us 12. Yes, this is where we are. Now, how do we get our answer for a? Remember I told you can actually write your constant with a 1 below it to make it look fractional the same way the first part appears. So since we have reached this level, what I want to do now is first to cross multiply. When I do that, 6 multiplies 1 to give me 6 is equal to a multiplies 12 to give me 12a. Now, my a is still carrying 12 along. I need to release the 12. The only way to do that is to divide both sides of this equation by the coefficient of a, which is by 12. So I'm dividing 6 by 12 as well as 12 by 12. And when you do that, 6 divided by 12 is the same thing as half. It reduces to 1 upon 2 is equal to a. You can rewrite this as saying that a is the same thing as 1 upon 2. Done. All right. Elimination method has just helped us to find the value of a within a twinkle of an eye. Easy. Now that I have applied elimination to finding the value a, I am going to use substitution to find the value for b. Substitution is direct. I already know the value for a as 1 all over 2. All I will need to do this time is to choose any equation, either 1 or 2, into which I can substitute a. So, pick any one and fill in a. I'm picking equation 1 first. So the next thing I'm going to do is to substitute the value of a. substitute the value of a. The value of a which we just found is 1 all over 2 here. So the value of a, which is 1 all over 2, into equation 1, since I am using the first equation 1 here. So if I do that, first, I already know that equation 1 has 2 all over a minus 3 all over b is equal to 2. That is what the question gave us. But since I will be substituting a to be 1 all over 2, the equation 1, which I already know, will now change. It will become something else. So the equation 1 will become something else. What will it be? Instead of writing 2 all over a, I already know the value of a to be half. So it's going to be 2 all over half. 2 all over half minus 3 all over b is equal to 2. Now we can find the value of b with ease. This is 2, okay? Alright. So if we divide 2 by half, first, that gives us the value 4. So now we have 4 minus 3 all over b is equal to 2. Are you there? Since we're looking for the value of b, the first thing I want to do, I can choose to multiply each term on both sides by b, but that may be a little lengthy. So the first thing I want to do is collect like terms. This is the only b term. I'm taking it to the right to make it positive. Why the 2 on the right hand side will come to the left to meet 4, and it becomes negative 2. So if I do that by collecting like terms, I'm going to have 4 minus 2 is equal to 3 all over b. Are you following? So at this stage, 4 minus 2 gives me 2, and I have 2 whole is equal to 3 all over b. You can as well make this 2 whole to be 2 upon 1. Fractional, just like the right hand side. Okay, now cross multiply. B multiplies 2 to give us 2b is equal to 1 multiplies 3 to give us 3. Since our focus is to find the value of b, right here we have to eliminate 2 by dividing both sides of the equation by 2. And if I do that, 2b on the numerator, the 2 cancels out the 2 on the denominator, leaving b alone on the left hand side. Whereby on our right hand side, we have just 3 all over 2. What it means is that the value of b is 3 all over 2, while the value of a is 1 all over 2. To write the solution set, we can say that for solution set, yes, a comma b is now equal to the value of a initially, we had it as 1 all over 2, comma, the value of b is now 3 all over 2. Yes, QED. We have just found the answers for A and B, and this is the solution set. You can always test it out to see if you're right by substituting the values you have found into the equations, any of 1 or 2, to see if you are right with the method. But I believe that this is clear enough. Alright, thanks for watching. Let's try something else.